The goal of this video is to say, all right, say we've got a function, whatever that function may be. How can we find the maximums and the minimums along that function? Because here's the thing, when you look at this function, if you think of this function as expressing something like your bank account or the profit you might make if you were going into some venture selling some good. Well, if this is your profit function, it would be very interesting to know how many units you would sell here, because this number of units sold would lead to the maximum profit. If this was your bank account over time, this would be the time corresponding to the most money made. So, well, when you look at this function as a whole, there's a maximum value there. And the maximum value for the function as a whole, we call an absolute maximum. So we say absolute because nowhere else does this function attain a higher value along the y-axis than there. Correspondingly, there is a notion of absolute minimum. And then you could ask yourself the question for this function, is there anywhere on the y-axis where the function goes no lower than that? And the answer is no, because when you look at this function, anywhere where you might say the function would hit a lowest value, in fact, it later goes lower. Because the function descends to infinity, we can say here, this function has no absolute minimum. When you look at the function as a whole, there's no value along the y-axis that is the absolute minimum for this function. There is an absolute maximum, but not an absolute minimum. And yet, as you're going along this function, if you consider sort of the path of travel, going up and then going down and then going back up and then going back down, almost like you're on a roller coaster going left to right, there is a point along the way where the function sort of does hit a minimum, where the function sort of hits a valley along the way. And this point is sort of minimal in some sense, not absolutely looking at the function as a whole, because as a whole the function descends to infinity, but looking within the locale of this point, the function does hit a minimum. So since this point is only a minimum within its locale, but not a minimum everywhere, let's just call it what it is. Let's call it a local minimum. Because within the locale of that point, it is a minimum. You're going down into the point, you're coming up out of the point, you must have hit a minimum. And let's just call that, though, a local minimum, because in the big picture, the function does go lower. In fact, it goes a lot lower, but within the locale, that's the lowest point. And with that notion of a minimum locally, you could also talk about a maximum locally. Anywhere on the function, is there a point where locally the function reaches a peak, where you're going up and then going down? And the answer is yes, like right here would be an example of a local maximum. Within the locale, this is a maximum. The function hits a peak. It's going up and then going down. In fact, the absolute maximum is also a local maximum. It just happens to be a local maximum, which is maximum for the entire function, so we call it an absolute maximum, but within its own local region, it certainly is the maximal value as well. Long story short, whenever you're trying to look for maximum minimums, you could call them local maximums, you could call them absolute maximums. Local minimums, absolute minimums. Local minimums, local within their region, they are the smallest value. Local maximum within the region, largest value. Absolute maximum, the maximum for all the function values. Absolute minimum, the minimum for all the function values.